Okay, so this is problem number 21 from chapter 4B of Hall and Knight higher algebra. This problem is slightly interesting. What this problem says is the number of terms in an AP is even. So we know that there are even number of terms. The sum of the odd terms is 24 and of the even terms is 30, and the last term exceeds the first by 10.5. Find the number of terms. Okay, so let us say that the AP has two n terms. Okay, this is the number of terms 2n, because it is even. It is given that the number of terms in an AP is even, so 2n will always be even. So let us say that the number of terms in an AP is n. So what our AP will look like? It will be A, second term will be A plus D, third term will be A plus 2D, and what will be the 2nth term? 2nth term will be A plus 2n minus 1D, right? So this is the AP. Now it is given that the sum of the odd terms is 24, right? So what are odd terms? Odd terms is A, then the third term which is A plus 2D, and then you will have the fifth term which will be A plus 4D, and you will have a term before this which will be A plus 2n minus 2 times D, right? So the sum of this is given to be 24, and we are also given that the sum of even terms is 30. So the second term is A plus D. After that we will have the fourth term which will be A plus 4D, and all the way up to A plus 2n minus 1D. Right? The sum of this this will be A plus D, and then the fourth term will be A plus 3D, okay, and then the sixth term will be A plus 5D plus A plus 2n minus 1D. This is given to be 30, and we are also given that the last term exceeds the first term by 10.5. So we are given that A plus 2n minus 1D minus A is equal to 10.5, which is 21 by 2. So we can see that A cancels minus A, so 2n minus 1 times D is equal to 21 by 2, right? What it also means is, if you add the original series, this should be equal to 24 plus 30, which is 54, right? Now from these equations we can solve for a, b and n. Let us consider the first equation itself. Okay, let us consider equation number 1. This is equation number 2, this is equation number 3, let us call this equation number 4. So if we consider equation number 1, from 1 we have, what is the number of terms? Number of terms is 2n, right? So sum is equal to 2n by 2, 2a plus 2n minus 1 times b is equal to 54, and we get an plus n times 2n minus 1b is equal to 54, right? Now 2n minus 1d is equal to 21 by 2, correct? So we get 2an plus n times 21 by 2 is equal to 54, or this means that 4an plus 21n is equal to 108. Right? Let us call this equation number 5. Now from 2, notice that this is also in arithmetic progression, right? In fact, you can write you can write the sum as a plus 2d plus a plus 4d plus a plus n minus 1 times 2d, right? 2n minus 2 can be written as a plus n minus 1 times 2d. This is equal to 24. So this is an AP where the first term is a, the number of terms is n, and the common difference is 2d. So what will be the sum? So from 2 the sum will be n by 2 times 2a plus n minus 1 times 2d, and this is equal to 24. So we can see that this cancels out and you get you get a times n plus n times n minus 1 d is equal to 24, right? So NA plus n square d minus nd is equal to 24, right? from 3 you can write 3 as a plus b plus a plus b plus 2d all the way to a plus b plus n minus 1 2d. You can rewrite this expression as this. You can expand and check it, right? Why? Because from here you will get a plus b, and from here you will get 2 nd minus 2d plus d is 2n minus 1d, right? So this is also an AP where the first term is a plus b, the number of terms is n, and the common difference is 2d. So you get n by 2 plus times a plus b into 2, that is n by 2 into 2 times a plus b plus n minus 1 times 2d. So this will again cancel, and this is given to be 30. So what you have is, you have a n plus b n plus n square d minus nd is equal to 30, and dn minus cancels, so you get n square d plus an is equal to 30, right? So let us say that this is equation number 6 and this is equation number 7. Now we know that n square d plus an is equal to 30, so this should also be equal to 30, right? So from 6 and 7 we get nd is equal to 30 minus 24, which is equal to 6, right? We know that n times d is equal to 6. Now, if you see equation number 4, we have 2n minus 1 times d is equal to 21 by 2. So, from 4 we have 2n minus 1 times d. d we can write as 6 by n. This is equal to 21 by 2, correct? So this is 3 times 2 and this is 3 times 7. So what you get from here is 2 to the 4, 4 to the 8, 8n minus 4 is equal to 7n, or n is equal to 4. So we have to find the number of terms. Okay, we have to find the number of terms. Number of terms is 2n. So if n is equal to 4, the number of terms will be 2n, which is equal to 8, right? Now once we know that n is equal to 4, we can actually find out d. D is equal to 6 by 4 or 3 by 2. Once you know D, you can also find out the value of A, right? We know the value of n is equal to 4. So from equation number 5 we have already found out n, we have found out the value of D. Now we have to find the value of A. So now let us say from equation number 5, right? This is equation number 5 here. We know the value of n. So 2an will be equal to 4 times 4an will be equal to 4 times 4 is 16a plus 21n is 16a plus 84. This is equal to 108. So A is equal to 108 minus 84. So this is 24 by 16. This is also equal to 3 by 2. So we know the value of A. So can we find the sequence? The sequence will be A, which is 3 by 2, plus A plus D. D is 3 by 2 again. So 3 by 2 plus 3 by 2 is 3. Now 3 by 2 plus 3 by 2 is 4 and a half, which is 9 by 2. So the sequence is actually 6, 15 by 2, 9, 21 by 2 and 12, right? So this is the exact arithmetic progression. And we are done.